everyone, welcome to my research video. Whenever we encounter pavement failure or pavement distress, such as potholes, cracks, or road cavings, we tend to attribute the cause of the failure to the quantity and quality of the material used for the construction. My doctoral research is based on the sticky plaque material that is used for construction of flexible pavements, which is bitumen. Bitumen is manufactured from crude oil at refineries using various processes. One such process of producing paving grade bitumen is by blending the residue obtained from auxiliary units in a refinery. So, what are these paving grades? In academics, marks are used to grade the performance of a student in a particular subject. Similarly, Bureau of Indian Standards grade bitumen for its application and use based on a specific parameter measured at specific temperature. Ever since the grading system for paving bitumen was introduced in India, the parameter used for grading has been revised at least 3 times. For every revision of this grading system, the refineries may have to tweak the processing conditions at the refinery to produce paving bitumen. My research story begins here. In 2013, when viscosity-based grading was introduced in India, the HPCL refinery at Mumbai faced issues in producing certain paving grades using blending process. The HPCL Green R&D Center Bangalore collaborated with IIT Madras to design a rational scheme of blending to produce the 4 paving grades. The materials used for designing the blending scheme were PDA pitch, which is as hard as rock at room temperature, extract, which has a consistency of honey at room temperature, and the third material was the residue obtained from distillation unit, which is as good as bitumen but a little softer. The first task at hand was to prepare a recipe for paving grade bitumen. I had to list out the proportion of material, let us call them blend components, the temperature at which they have to be blended, and the duration of blending. There was a catch. There were constraints on the quantity of materials as well as the temperature range at which they have to be blended. Using applied statistics concepts, the blending scheme was designed. The next task at hand was to evaluate the compatibility of the blend. In other words, we had to assess whether the blend components are mixed well and are stable such that they don't separate out when we use it for construction of pavement or during its service life. Using solution chemistry concepts, the highest compatibility parameters were computed and the stability of the blends were quantified. The third and the final task was to understand the in-service behavior of blended bitumen. To characterize the in-service behavior, the blended bitumen samples were subjected to large shear deformations and the response was quantified. Over a wide range of temperature, it is likely to get subjected to during its service. Using the inferences obtained by carrying out the tasks, I was able to get a better understanding of how to formulate a good recipe for better bitumen.